Okay, hello Year 11s. This is another question that I'm using your textbook to find a source of problems for. And what I've done is I've decided I'd like to have a go at 8a question 17. Now it happens in three parts and not all of them involve proofs. So the first part says to expand this expression here. So let's see, what we really want to do is say x times x squared, well x times x squared is x cubed. Now x times xy will be x squared y, and x times y squared will be x y squared. Now the next one we're going to do is minus y times x squared, so that'll be minus y times x squared. Minus y times xy will be x y squared, and the last one will be minus y times y squared, which will be minus y cubed. Now if we have a look here and see if we can try to simplify something down here, well x squared y is the same as this one over here, so these two will cancel out because one's positive and one's negative. Now xy squared, well, these two are the same, and these two will cancel out, which will leave us with just this first one here, x cubed minus y cubed. So there's the first part we've done. Okay, Year 11. So here's the second part of 8a question 17, part B. Alright, it says we've got to prove x squared plus xy plus y squared is always greater than or equal to 0, where x and y are elements of the real number. So x and y are elements of the real numbers. That means they can be fractions, square roots, negative numbers, positive numbers, whole numbers, anything like that. Okay, now we've got to prove this part. Now, it gives us a bit of a clue in the question. It says use the use completing the square. So let's see if we can do that. So x squared plus xy. Now I'm going to leave a little bit of a gap and put in y squared there. Now, well, let's see here. How can I do completing the square? Well, my idea is to say, well, x squared plus xy. And what I'll do is I'll break up this y squared to be y squared over 4 and 3/4 of the y squared over there. Now that means I still have one whole y squared, but there's 1/4 of it here and 3/4 of it there. Now these three I can factorize to become a perfect square, and they will become x plus y over 2 all squared, and I'll have 3/4 of y squared over here. Now this is always going to be greater than 0, and the reason you can tell is because x plus y over 2 squared is always going to be greater than 0, because anything squared is always greater than 0. So as x plus y over 2 squared is greater than 0, and now if 3/4 of y squared, well that'll be greater than 0, because anything squared will always be greater than 0, and 3/4 of y squared, since it'll be greater than 0, will also be equal to 0. Therefore we can say x squared plus xy plus y squared will be greater than 0. So here's the third part of the proof. So if x is greater than y, prove that x cubed is greater than or equal to y cubed. So what I'll do is I'll take this y cubed across to the other side. So I'll say x cubed minus y cubed. We have to make that greater than 0. Now this is the first part of the problem back again. This is part A, whereas previously we had to expand it and we ended up with x cubed minus y cubed. This time we're going to factorize it. It's the difference of two cubes. So the answer will be x minus y, x squared plus xy plus y squared. Now, how can we prove that this is always going to be greater than 0? Well, if we use this bit of information here, if x is greater than y, then we can say x minus y is going to be greater than 0, which means that x minus y is greater than or equal to 0. And this part here is the part in part B, and we found that x squared plus xy plus y squared was always going to be greater than 0. Therefore, x cubed will always be greater than y squared, because if this part is greater than 0 and this part is greater than 0, then that means this bit must be greater than 0, which means this must be true. Alrighty, Year 11s, well, I hope that helps with some of your work. If you have any more questions, please ask me in class.